Hello, this is Ms. Schultz here, making my first ever instructional video, so I hope you'll be a little bit patient with me. You need item 2-7 out. My page is going to look slightly different than yours, but really pretty much the same. We're going to be learning about balancing equations. So first you need to know that atoms are not created or destroyed writing with this thing is funny during a chemical reaction. Scientists know there must be the same number of atoms on each side of the equation. If you remember from last class, we talked about the law of the conservation of mass or matter that said that you can't have two atoms of an element go into the equation and only one atom come out. It has to be the same on either side of the equation. You should be writing this down, by the way, on item 2-7 at the top. To balance the chemical equation, you must add subscripts in front of the chemical formulas in the equation. You cannot ever add or change subscripts. You are just not allowed to do it. That's because if you change the subscript, you would be a wizard who could change the identity of an element. For example, if you had some water, H2O, and you were to add a 2 onto the end, you no longer have water, you now have hydrogen peroxide. You cannot change water to hydrogen peroxide. But what you can do is change how much water is present in the equation. All right, moving on. So here is a chemical reaction. This is one you actually saw at demo day, where we took the magnesium ribbon and we burned it. And remember, I showed you afterward we had this white stuff that looked a little bit like twist ties in the end. That was magnesium oxide. Now if you see in this equation, we've got some magnesium combining with some oxygen, and we get magnesium oxide. And the first thing we're going to do is make ourselves a count to see how much of each we have. So as you can see here, there's just one magnesium atom on this reactant side, but there are two oxygen atoms. Do you see the subscript tells you that there are two bonded atoms of oxygen? On this side, we have one atom of magnesium and one atom of oxygen. And you probably remember that this goes against the law of the conservation of mass or matter. Two atoms of oxygen went in and only one atom of oxygen came out. The magnesiums are fine, they're balanced. Now what some of you would probably like to do is just to come over to the side of the equation where the magnesium oxide is and change a subscript. If you put a little 2 there, you might be good, but you can never ever change a subscript. The only thing you can do is add or change coefficients. So if I put a coefficient of 2 here, I now have two magnesium oxide atoms. Let me show you what it would look like. A magnesium oxide would look like this, and magnesium and an oxygen. But a second magnesium oxide would look like this, one magnesium bonded to an oxygen. So as you can tell here, there are now two magnesiums. I think we're good now. All right, there are now two magnesiums, so I'm going to cross this out and put a little 2 here, but there are also two oxygens. The coefficient goes with the whole term, the magnesium and the oxygen. So now you can see our oxygens are balanced. 2 oxygen here on the reactant side, 2 oxygen here on the product side. But the problem now is the magnesium. There's only 1 here on the reactant side, but there's 2 here now on the product side. So remember, we can never, ever, 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 ever change the subscript, but we can change or add a coefficient. So we're going to go back here to the reactant side and change this coefficient to a 2. And when we do that, we now have 2 magnesiums on this side. Now our equation is balanced. 2 magnesiums on this side, 2 magnesiums on this side, 2 oxygens on this side, 2 oxygens on this side. So what we did was just change how many magnesium atoms are taking part in this reaction. All right, we are going to move on to some of the examples under try these. Hold on. I am actually skipping the one. Hold on a minute. I'm actually skipping the one that starts with Ca, only because it balances exactly like the one we just did. So I'm skipping on to this one that starts with N2. First thing we're going to do is make our count, right? We're going to count how many atoms of each element are participating in the equation. So we've got 2 N's on this side. Hold on. Okay, we've got 2 N's on this side. We've got 2 H's on this side. But let's look carefully here. We've got 1 N, but we've got 3 H's. So this is not in balance at all. So we're going to need to think carefully about what we're going to do here. I believe we're going to start with the N's to see if we can figure out how to get the same number on each side. So if there's 2 here on the reactant side, we want to get 2 here on the product side. And the way we can do that is by putting a coefficient of 2 right here before the whole compound. That gives us 2 N's like we wanted. But it also gives us how many H's? Well, let's think about it for a minute. We have an NH3, which would look like this. An N with 3 H's. But look, we have 2 of those. So we need to draw it out twice to get a picture of what we're doing here. So now looking at this, how many N's do we have altogether? 1, 2. But how many H's do we have altogether? Well, there's 3 here and 3 here. Altogether, that makes 6. Now, a much faster way to do that is just to multiply the coefficient times the subscript. 2 times 3 is 6. So now we've got our N's in balance, and 2 here and 2 here. Now we just need to get our H's in balance. So we're going to come back over here to the reactant side and think of what we could put here so that we have 6 hydrogen on the reactant side, just like the product side. So if we turn this coefficient into a 3, 3 times 2 is 6, we would end up with 6 H's here, which gives us a balanced equation. 2 N's go in, 2 N's come out. 6 H's go in, 6 H's go out. All right, moving on to... Okay, so this is your next example on your paper, and I actually see I've made a little mistake. This is my first movie. This is missing an O right here, so I'm just going to kind of add it in there. So first thing we're going to do is make our count. 2 Cu's, 1 O, 1 C. On the product side, 1 Cu, 2 O's, and 1 C. So as you can see, the carbons are in balance, but the oxygens and the Cu's are not. So we're going to start with Cu. We can put a coefficient of 2 here, and that gets our Cu in balance. And then we can look at oxygen here. 2 oxygen over on this side, but only 1 on the reactant side. So we can put a coefficient of 2 up here. And when we do that, that gives us the 2 oxygen we were looking for. But unfortunately, it also gives us 4 Cu. Coefficient times the subscript would give us 4. So everything is in balance here now except for Cu. So all we're going to need to do is fix this coefficient. You're allowed to change or add coefficients. So all we need to do is change this coefficient to a 4. And then we end up with, won't let me write that, we end up with 4, which gives us another balanced equation. All right, this is an example of a slightly harder one. You won't see too many like this, but the reason this is a little bit harder is you'll notice that on the product side, there's oxygen in 2 different places. Here, oh, my pen's not going, here and here. So you're going to actually have to add those oxygens together. So let's start with, we have our list. So we have 2 hydrogens on this side and 2 oxygens on this side. And over on the product side, we have 2 hydrogens, but we have 3 oxygen. There's 1 here and 2 more here. So you have to add them together, actually getting 3. I know that's a little trickier. So we're going to look here how we're doing. It looks like our hydrogens are balanced, 2 on each side, but our oxygens are way off. So generally what I do when I have something like this, so what some of you may be wondering is, how can you possibly get the same amount of oxygen on each side of the equation? And the best way to think about this is to think about math and the least common multiple. So if you look at the numbers 2 and 3, the least common multiple, the smallest thing they both divide into, is 6. So let's try to get 6 oxygen on each side. So, oh, that's going to be tricky. Actually, that's probably not going to be a great way to go. Let's just scrap that for a moment. And this is going to be one of those that it's probably going to make a little more sense to just try putting in some coefficients to see what happens. There's always going to be a billion ways you can go about balancing an equation. But this one, I think I'm just going to start by saying, all right, well, let's see if I put a coefficient of 2 here. What happens? What is that going to change? Well, I'm going to end up with coefficient times the subscript. I'm going to end up with 4 hydrogen here. And I'm going to end up with coefficient times the subscript 4 oxygen here. So then going back to my other side, is there a way that I can make, all right, well, how, if I have a 2 as this coefficient, I'm going to also need to have a 2 as this coefficient in order to get 4 here. So if I put a 2, I now have 4. And let's see what that's done to my oxygen. I have 2 oxygen here and 2 more here, which actually would give me the 4 I was looking for. That's a pretty tricky problem. We aren't going to do too many like that, but there is a challenge on the back of your paper where you're going to have to add elements together like that. All right, we're going to do one more example from the back. This is actually your second example from the back. And the only thing that's different about these problems is that nobody has made the list for you. You have to make this list yourself. So all you're going to do is look and see which elements you have present. You have Na and you have Br on this side, and you have Na and Br on this side. One of the most important things to remember is you have to make your list in the same order. If Na comes first on this list, Na needs to come first on this list. You always want to have your elements in the same order so you can compare them more easily. Then you do what we did before. You make your count. 1 Na on this side, 2 Brs on this side, 1 Na on this side, 1 Br on this side. So now we say, well, the Nas are good, they're balanced, but the Brs are not. We've got 2 on the reactant side and only 1 on the product side. So if we put a coefficient of 2 here, that will give us the 2 Brs we wanted, but it'll also change our Na count to 2. So our Brs are now good, they're balanced, but Na is not. 2 on the product side, 1 on the reactant side. So all we need to do to balance this one is to put a 2 right here, and we get the 2 Nas we were looking for. Now what I would like you to do is to complete the rest of the problems on this page. And if you have any issues, let me know. The challenge problem is pretty challenging, but I'm betting that there are some of you that will think this is fun and really want to give it a try. I hope you liked my first movie.